Welcome fellow learners. Today we are diving into the next part of our tutorial series on conversational data processing using Langchain. In this video, I will walk you through the code on how to create a SQL database chain using Langchain. So whether you are a data enthusiast, a data scientist, or just curious about how AI can integrate with the data, you are in the right place. We will first import and prepare the data, convert it into a data format that can be easy for AI to understand, and finally interact with it using LangChain and natural language. So just grab a cup of coffee, be comfortable, and let's start coding. In this tutorial series, we will be utilizing the renowned Titanic dataset available in the Kaggle. This dataset consists of various columns, including passenger ID, does those passengers survived or not, passenger classes, their name, their gender, their age, and many others. We will later explore these columns to formulate the queries for interaction with the language model. Now let's jump straight into our coding segment. As our data is in CSV format, which necessitates the use of Pandas library for data manipulation and data visualization in the Jupyter Notebook. We will commence with importing the library. So we will run first cell. Now our library is imported. We can use read CSV function to import the data directly into this data frame. This will create a data frame named data. So now our data frame is created. We can use head function to print top 5 rows from the data. Now we can see it has shown the 5 rows from the data, which includes all the columns which we have seen in the CSV file, like passenger ID, survived, passenger class, name, gender, age, and many others. We can also print how many rows does this data contains and the various data types of each of the column in the data set. We'll run this cell. We can see this data set consists of 891 rows, and we can also see the data type of each of the column, like passenger ID is in int format, their age is in float format, and others like ticket is in object format. So this way we can also see the data type and the number of rows it contains. Now we have our Titanic data as Pandas data frame. Next thing is we will transfer this data frame into SQL database for more efficient querying and data handling. For this we will be using SQLite 3 library. Next we will import connect function from SQLite 3 library. This connect function will basically connect to a database named titanic.db. If this database already exists, it directly loads the database, and if it does not exist, it will create an empty file named titanic.db. Further, we will use two SQL function from the data frame to input all the rows from the data frame to the database under the table name passenger.data. We can also use an argument name if exists. Like if this table already exists in the database, it will just replace that table. But in our case, it will first create an empty file named titanic.db, then input all the data from our data frame to this particular database under table name passenger data. We will run this cell and we can see it has entered 891 rows from the data frame to this particular database, and the table is passenger data. We will further use SQL database class from Langchain community to interact with the data, and this SQL database will further be used when we will create our SQL database chain. So we will run this cell, and then we can use from URI function from SQL database to basically load the database name titanic.db. We can also use an argument named sample rows in table info to sample number of rows. Here we have used 3 rows to just preview or get an overview of the table. So we will run this cell. We can see it has given us the schema of the table, like this table has all the columns from the database and also the data type of each of the column. So like passenger ID is in integer form, their age is in real, which basically in the float, and other columns are also there. It has also shown us 3 rows from the data. It has printed it over here. Now we have our database. Next thing is we will initialize a language model using Langchain OpenAI library. So in this case, we will be using GPT 3.5 Turbo model from OpenAI. We will first run this cell and import chat OpenAI class from Langchain OpenAI library. Now you can see I have used few parameters over here. The first one is temperature. So temperature basically keeps track of randomness in the generated output from the LLM. I have used temperature equals to 0, which makes the output more deterministic. Next, I have used OpenAI API key. I have stored my OpenAI API key in system variable so that I need not to enter every time whenever I am trying to use this model. So I can get this OpenAI API key using environment variable. For that I have imported OS, and then I got it using os.env1.get. I have kept a name of the OpenAI API key as OpenAI underscore API underscore key. So we will run this cell and see if it loaded our language model or not. We can see it has correctly loaded our model. It has used our OpenAI API key directly over here. So we have our language model, we have our database. So now we will create our database chain directly. For the chain part, we will be using SQL database chain class from the language experimental from the Langchain. So basically, we will input database and LLM to SQL database chain. So this will create an interface so that you can query your questions through the database and get the output from LLM. We will run both these cells. So this will import SQL database chain, and the next it will basically create a SQL database chain. Now we have our chain. Then we can directly use the invoke function, which basically helps us to query through natural language and get the output from the database using the language models. And also, if you see, there is another parameter I have used, verbose equals to true. It makes sure if there are any hidden steps that are being involved in querying process, that can be printed out over here so that it can be beneficial in debugging step, and also it can be helpful for the educational purpose. So we will run this cell and see what steps does it uses. So as we can see, this is our question: how many passengers were there? It first created an SQL query. So we can see the SQL query like select count passenger ID as total passenger from passenger data, which seems correct. Then it will run this SQL query to our database, and it ran and it got the output as 891. And then it basically uses this SQL result and the question that we have used, like how many passengers were there, and then generate the final response using the LLM. So it given us a final response as total passenger 891. We can verify this result from our database, which was originally in CSV format. We can select any column, and we can see there are basically, I think there is some filter involved here. I can directly remove the filter, and then we can see how many rows are there. So there are total number of rows are 891. For the total count is 892 for the header also. So we can see it has given us the correct output over here. We can run few other basically you can say queries. Like there are few other columns. One is survival rate, survived column. Another is passenger class column. We can ask questions like how does this survival rate varies with respect to passenger classes. So I have written question over here already, like how does survival rate varies on the basis of passenger classes. We will run this cell and see how does it work. So we can see it again first generated SQL query through LLM. It just given it input of this how does survival rate varies on the basis of passenger classes, and the table schema and the top 3 rows to it. Then it created this query like select P class average survived as survival rate from passenger data group by P class order by survival rate, and it also used descending order and limited it to 5. And then it basically ran this query through our SQL database, and it has given us output like this. And then it used this SQL result and the input question, take it as input to the LLM, and then it generated the final response to us. Like you can say it has summarized it well. The survival rate varies based on the passenger classes as follows. If for the P class 1 it is 63, for P class 2 it is 47, P class 3 it is 24. It has also somehow approximated it, so it's like 0.6296. It has summarized it to approximated it to 63%. We can verify this result from our database. We can create a filter to this passenger class. Like I will create a filter over here. Then we can select any one of it. Like I will select the P class 1, and then we can see the basically average in the survived column. We can see it is 0.6296, which is equal to the output we can see over here, 0.6296. So that wraps up our deep dive into creating an interactive database using Langchain and LLM. Today, we have covered everything from importing the dataset, converting it into SQLite database, initializing a language model from OpenAI, and finally querying the data using the Langchain. For now, you should have solid understanding of how these components work together to create a powerful tool to interact with the data using natural language. In the next video, we will implement each component of the SQL database chain individually. So yeah, thanks for making to the end of the video. Goodbye until the next time.